Hello guys, so today we're going to be doing we're going to be doing the differential equations, and in particular first order linear differential equations. So if I had a differential equation like dy by dx plus 3y should be equal to 4x. Now this is a first order linear differential equation. Why is it a first order differential equation? This is because if we look at this and this, well, mostly just this right here, it is to the order of 1. It's a first derivative. Now the second derivative would be denoted by d squared y by dx squared, and we'll look at how to do those in the next video. But right now, this is just all you have to know. This is what a differential equation is. It's really just involving dy by dx in the equation, because normally when we find dy by dx, we're just trying to get a result, but here it's actually a part of the equation. Cool. So how do we go about solving these? Well, to solve them, we just first have to understand the format of a first order linear differential equation. So once you know the format, you're going to be able to solve any question. So we're just going to have to put any differential equation we get into this format. We're going to have dy by dx plus p of x times y should be equal to q of x. And so p of x represents anything. It could be any function. I personally don't like when people say function because it makes me a little lost, but I just mean it could be e to the power of x, it could be anything at all, right? We just don't know what it is. It's just an example, it's a placeholder, and the same thing for q of x. And when we get it into this form, and kind of always remember that this is 1 right here, there's nothing beside the dy by dx. This should always be like that. And when we get it into this form, we can then solve the equation by getting an integrating factor. Now, I don't know what an integration factor is myself, but I know how to solve first order linear differential equations, which is what you have to know for CAPE Unit 2. So what we're going to have to do is we're going to say the integrating factor, which is I of x. Well, I call it I of x. Some people call it I. Some people don't even call it anything, but I like to call it I of x is equal to e to the integral of p of x dx. Now, the p of x here is just the coefficient of y, so it's e to the power of the integral of the coefficient of y dx. Cool. And what do we do with the integration factor? Well, whenever we get that, what we're going to do is we're going to say we're going to have y times the integrating factor should be equal to the integral of q of x times the integrating factor dx. And that's legit all of first order linear differential equations. This is all you have to know. This is the principle. If you understand this, then we can move on and you'll hopefully understand the rest of the video. So if I gave you an example and I said I wanted you to find dy by dx plus 3y equals e to the 2x, how would you go about doing this? So if I was you, I would remember first of all the form. So we know that the form should be dy by dx plus p of x times y should be equal to q of x. Now in this case, we need to find the coefficient of y, which is 3, and we need to make sure that the coefficient of dy by dx is 1, which it is 1 here, so that's fine. And so we know that q of x is equal to e to the 2x, so I'll just write that down here. So p of x is equal to 3, q of x is equal to e to the 2x. So what do we do now that we know that? Well, if you remember, we just have to find our integrating factor, and our integrating factor, I of x, should be equal to e to the integral of p of x with respect to x. Now, what is p of x? Well, p of x, we just wrote it down right here, is 3. So that means that I of x is equal to e to the integral of 3 dx. And when you have the integral of 3 dx, it's just going to be equal to the e to the power of 3x. The integral of 3 is x. The integral of 3 is 3x, or well, we could pull it out and have the integral of 1, and the integral of 1 is x. Any way you like to do it. If you don't understand how to do that, you should probably revise integration. But nonetheless, this is our integrating factor. And now that we have that, what is it that we need to do again? Well, all we have to do is put y times the integrating factor should be equal to the integral of q of x times the integrating factor dx. And well, we've kind of already gotten our answer low key, right? Low key. So we have I of x is equal to that. So we're going to say y e to the 3x should be equal to the integral of q of x. Remember, we put our q of x as e to the 2x, so it's going to be q of x, which is e to the 2x, times e to the 3x dx. We're going to say y, e to the 3x, is equal to the integral of, well, the base is the same, we just add the powers, e to the integral. Those are the integral of e to the 5x dx. And hopefully you know how to integrate, but if you don't, when we're dealing with e to the power of ax, so if you have an integral of e to the ax, and a just stands for any constant value, what we're going to have is going to be equal to 1 over a times e to the ax. So all we have to do is really bring down the power, divide by the divide by that, and we should get our answer basically. So we're going to have y, e to the 3x, should be equal to 1 over 5 e to the 5x. And actually, before, just in case it gets confusing, this, you should actually just take the derivative of the power of the exponent. So in this case, the derivative of ax is just a, and divide by that. So 1 over the derivative of ax, which is just a. Just because if you're doing differentiation, this might get a little confusing sometimes, but that's all you have to know for there. For that. And remember that this is unbounded integration, so we're going to have plus c. And what you typically should do is just get y to one side, but you've actually kind of gotten the answer already. But let's just put y to one side, so y is equal to 1 over 5 e to the 5x over 3x is 5x minus 3x is 2x plus c e to the negative 3x. If you don't understand how I did that, you should definitely revise your exponent rules, and then you'll understand. But mainly I just use the fact that we would have 1 over, let me put in a different color. What we would have had is 1 over 5 e to the 5x over e to the 3x plus c over e to the 3x. Now in this case, when the bases are the same and we just have different powers, we're just going to subtract the powers, so we're going to have 1 over 5 e to the 2x plus c, and now here we can bring a denominator to the numerator if we just make the power negative, so c times e to the negative 2x. And that's all we did. Sorry, that's actually 3x. But yeah, so that is the general solution. Now, okay, so I'm going to be doing 2021 right now as your very first past paper example. So from the content that you just learned just a while ago, well, you'll be able to do pretty much any past paper question. You just really have to think about what it is that you're doing. So what I mean by that is, first of all, what I like to do is rewrite the question. So the question says dy by dx times tan x plus y minus 2 cos squared x equals 0. And immediately under that, I like to write the actual format of a first order differential equation. It's first order because this is to the power of 1, it's the first derivative, so I know it's first order. So I just like to write the format of that, which is dy by dx plus p of x times y should be equal to q of x. Now, because we know this, what we can do is we can transpose to kind of make this follow the original format. So what we'll have dy by dx of tan x plus y is equal to 2 cos squared x. Now, are we done? So can we start doing our normal stuff right now? Well, we see that there's p of x and there's q of x, and we have our q of x now, and we have our p of x, which is probably just 1. But if you notice, we have dy by dx times tan x, and it's supposed to be multiplied by nothing. Dy by dx should not have a coefficient. It should not be multiplied by anything. So to get rid of that, we have to divide everywhere by tan x. So divide by tan x over tan x. Now when we do this, this will cancel out, and it will all go back to good stuff. Everything will be hunky-dory. So we're going to have dy by dx plus 1 over tan x times y should be equal to 2 cos squared x over tan x. Now, what do you know about tan x? Well, first of all, I just like to fix this part over here. So it's really the same thing as saying 2 cos squared x divided by tan x. And divided by tan x is, well, tan x is just the same thing as saying sine x over cos x. And when we're dividing a fraction, what we can do is we can just flip the fraction and multiply the flipped fraction. So instead of sine x over cos x, we'll have times cos x over sine x. And this will just give us 2 cos cubed x over sine x. So 2 cos cubed x. I'm just to write that down. I'm just trying to be as efficient with the space as possible over lean line over sine x. And so we have that right now. Cool. Now what do we have to do? We have to find our integrating factor or coefficient. I don't remember which one it is because I don't think anyone really cares exactly, but we notice that the integrating factor is e to the integral of p of x dx. So in this case, what's p of x? Well, p of x is the coefficient of y. In this case, the coefficient of y here is 1 over tan x. So we know that 1 over tan x, well, we know that, I'll just write this in a different, oops, it should not be there. So we know that 1 over tan x is the same thing as saying 1 over sine x over cos x, which is equal to 1 divided by sine x over cos x, which is equal to cos x over sine x. Which means that if we're trying to find I of x, which is equal to e to the integral of p of x dx, this will be equal to e to the integral of cos x over sine x dx. Now, what is peculiar, not peculiar, but what's something, well, sorry, not what is, but something that you should realize instantly is this format. And this is the format of the integral of integral differential of, f prime of x over f of x dx, which is equal to ln of f of x plus c. Now, in this case, if you look at this, the derivative of sine is cos, so it's going to be f prime of x over f of x. So what we're going to have is ln of the denominator, which is f of x. So it's ln of f of x plus c, where f of x in this case is just sine x. Cool. So now that we know what the integral is, what we can just do is we'll say it's e to the ln sine x. Now, something you should note is we don't typically use plus c when we're putting it up here. We just add it at the end. I don't actually know why, so don't ask me. But we don't put plus c when we're dealing with the integrating factor. So now we know that I of x is equal to this. But if you notice, the relationship between e and ln is that they're inverse functions of each other. So somehow these two kind of cancel out, and we're left with it being equal to sine x. Now, if you remember how to actually solve it, well, we solve a differential equation by having y times I of x should be equal to the integral of q of x times I of x. And in this case, y times sine x is going to be y times sine x, because that's our integrating factor, should be equal to the integral of what's our q of x. So we look up here, under q of x is this value here, 2 cos cubed theta, or x in this case, over sine x. So it's the integral of 2 cos cubed x over sine x times our integrating factor, which just so happens to be sine x, so times sine x dx. And these two things cancel out, so we're really left with y sine x should be equal to the integral of 2 cos cubed x. Now, this question is really building on foundation that you should have from integration, which is how to integrate trigonometric functions to the power of 3. Now, you have to learn how to do it to the power of 2 and to the power of 3. But in this case, what we're going to do is we're just going to factor it out. So we're going to have y sine x should be equal to the integral of, we'll pull the 2 out, 2 times the integral of cos x times cos squared x. Now, why do we do this? Because we know from Unit 1 that cos squared x is equal to 1 minus sine squared x. So we can plug this in, because this is just how we integrate cos x to the power of 3. So we plug that in, and so we'll get y sine x should be equal to the 2 times the integral of cos x times 1 minus sine squared x dx. Now what can we do next? We'll simply FOIL and just expand the bracket, so we'll have y sine x should be equal to 2 times the integral of cos x minus cos x sine squared x dx. Now, here's the thing, what we can do now is just integrate. But if you notice, or if you haven't noticed, I'm about to explain, this question, as I said, uses lots of the foundational knowledge. So the first one was if we had the differential is the first thing, like the differential is the numerator and the normal function is the denominator. Well, in this case, this is a little bit different. It's another thing that you need to know, which is what happens if you're multiplying. Okay, so in this case, you're multiplying f prime of x times f of x to the n. Okay, well, what do I mean by that? Well, what is, let's just break this down. So in this case, we have cos x sine squared x. What's the differential of cos x? Well, the differential of cos x is sine x, is negative sine x, sorry. Yeah, so the differential of cos x is negative sine x, and don't forget that we have a negative sign here. And this negative sign is being multiplied, so it distributes to everything. So what we could actually write this as is, we could write as, well, actually no, let's just not do that. But we'll just do the negative sign, actually. But yeah, so we're going to have negative cos x times sine squared x. So this follows the form where we're going to have f of x times f prime of x raised to the power of n. Now, this is another standard form you just have to learn. In this case, what the standard form is f prime of x to the n plus 1 over n plus 1. That's going to be your answer here. And it really just comes down to you being able to be conscientious enough to see that this is in the same form that you need it to be. So let me just word that out. So wait, sorry. Did I say that right? Oh my gosh, no, I didn't say it right, sorry. I'm a little lost. Okay, sorry about that. So I accidentally just said something incorrect, but let's just go. So when we see this side right here, what we're going to have to do is break it up, and we see this now. We might think, well, product rule is two things are being multiplied, but in fact, this is just a standard form of integration. When we have to integrate this, what this is, it follows the form, the integral of f prime of x times f of x to the power of n. So you have to know this form, you have to be conscientious enough to see this form, which is why this topic is really, not this topic, this question is very heavily based on integration and differentiation. So hopefully you understand those so far, but this is just a general result, and you should probably remember this. If you have f prime of x times f of x to the power of n, this is how you find the integral of it. The integral will just be, it will be, I believe it's going to be f of x to the n plus 1 over n plus 1. So in this case, right, f of x is sine x, and we know that the differential of sine x is just cos x. So in this case, f of x should get this done to it, right? So we're going to have y sine x is equal to 2 times the integral of cos x minus, and well, what do we do? Since it's sine squared x and this is cos x, what we'll do is, since sine x is the f of x, we'll do minus sine to the power of 3x over 3. Sorry, by the way. This, I made a mistake again. That's the actual integral. Like, this is the result for the integral. So what we have to do is integrate this first. So it's going to be equal to 2 times the integral of cos x is negative sine x, so negative sine x. Sorry, it's positive sine x. Is it positive sine x? Yeah. Yeah, so positive sine x. And then this part now, that part over there now becomes minus sine cubed x over 3. Okay? But we're not technically done. We have to add plus c, but that's the least. So now what we have is y sine x is equal to, what is equal to, this is equal to 2 sine x minus 2 over 3 sine cubed x plus c. Now, whenever you see something like this, we just need to make y the well, not the subject, but we need to make y isolated. This will leave us with y is equal to 2 minus 2 over 3 sine squared x plus c over sine x. So what did the question ask us to get? The question asked us to get y is equal to 5 over 3 plus 1 over 3 cos 2x plus c cosec x. But we don't have something in that form. So what it really means that we have to look at both of these equations. We have to look at this and the original equation and see what the difference is. Well, the difference is that it needs a cos 2x. So what that means is we have to relate cos 2x to sine squared x. And luckily enough, that is actually relatable, because if you remember from your double angle formulas, cos 2x is equal to 1 minus 2 sine squared x. That means if we're supposed to find sine squared x, that would be sine squared x is equal to 1 minus cos 2x over 2. And that's just me transposing. Yeah. So in this case, what we can do is we can take this value and plug it in here instead of having sine squared x. So what we're going to have is we're going to have y is equal to 2 minus 2 over 3 times 1 minus cos 2x over 2 plus c. And remember, 1 over sine x is equal to what was equal to cosec x. So this is the same thing as that. So instead of saying c over sine x, we're just going to have c cosec x. And now we just have to expand brackets, and I think we should get the answer. So we're going to have y is equal to 2 minus, it's going to be minus 2 over 6, then plus 2 over 6 cos 2x plus c cosec x. If you didn't see how I did that there, remember that 1 minus cos 2x over 2 is just simply equal to 1 over 2 minus cos 2x over 2. And then I multiplied these by 2 over 3 separately. So I multiplied 2 over 3 by this, and then 2 over 3 by this separately. So that's why I just separated it, but hopefully you're following along with that. But if you didn't, then that's exactly what we did. Now we can just simplify. Y is equal to 2 minus a third plus a third cos 2x plus c cosec x. And 2 minus a third is the same thing as saying what? It's the same thing as saying 6 over 3 minus 1 over 3. Because 6 divided by 3 is 2. And 6 over 3 minus 1 over 3 is just 5 over 3. So y is equal to 5 over 3 plus a third cos 2x plus c cosec x. This is our answer. So let's go back up and check if that's what the question asked. 5 over 3 plus 1 over 3 plus, yep. So that is the very first question. And yes, this was technically just based on the foundation, and it was kind of a little bit more difficult. It was based on a lot of all the foundation different from what I just taught. But if you knew that already, which you probably should because this is from module 3, then you should probably be chilling. So let us go into another example. This example is a little bit easier. I think when I was working it out, I thought it was a little easier myself. Well, not for this video, but for CAPE, because I just did CAPE. And yeah, that was kind of brutal, I can't lie. But again, let's just rewrite the equation. As soon as we get to rewrite the equation, so we're going to have x dy by dx plus y should be equal to 2 sine x. Okay, so we have that. Well, what do we do now? We have to find a way to make this go away. But if you're not following, let's just write the general formula one more time. This is the last time I'm going to write the general formula. If you don't remember it now, I'm just going to start assuming that you remember it, so probably try to remember it. So remember, the general formula is dy by dx plus p of x times y should be equal to q of x. Now in this case, we notice that x is here and there should be no coefficient of dy by dx. It should be alone. So to do that, we divide everything by x. So we'll have dy by dx plus 1 over x times y should be equal to 2 sine x over x. And so now we closely have the exact same format as the I don't know, I forgot what I call this, but the foundation equation. Yeah, it has the exact same format. So now what we have to do is we have to find our integrating factor, which is I of x. Remember, that's going to be equal to e to the integral of p of x dx. P of x in this case is 1 over x, so it's going to be e to the integral of 1 over x dx. Now the integral of 1 over x is just ln x, so it's e to the ln x. And again, we don't put the plus c when we're dealing with the integrating factor. Now again, with the inverse function, we're just going to be left with x. So then, if we take y and multiply it by the integrating factor, which is x, so y times x should be equal to the integral of q of x. Now q of x was q of x is right here, is 2 sine x over x. 2 sine x over x times x dx. These two things cancel out. We'll have yx to be equal to the integral of, well, we can pull out 2 sine x dx. And what do we do next? Well, we can say yx is equal to, what's the integral of sine x? This is going to be, so the derivative, so the integral of sine x is negative cos x, I believe. So the derivative of sine x is cos x. The integral of cos x is sine x. The integral of sine x is the negative 2 cos x plus c. So far, let's see what the question asks us. The question asks c over x minus 2 over x cos x. And we kind of already have the answer, so we just have to divide both sides by x to get y by itself. So the general formula is going to be y is equal to negative 2 cos x over x plus c over x. Okay, and now we're going to be doing 2017. Alright, so again, just to reiterate, we're going to rewrite the equation first. So we're going to have 1 plus x squared times dy by dx plus 2xy equals the cube root of x. Now, as I said last, we're not, well, actually, did I say it? I'm not sure if I said it, but we're not going to go and write the form anymore. I'm just going to go and actually start working the question out instead of rewriting the form. By this time, I'm hoping that you understand the form. So let's get started. First of all, I'm going to convert this from the cube root of x like that to x to the 1 over 3. I just think it looks neater and it's easier to work with. So what we're going to be left with after we divide by 1 plus x squared, we're going to have dy by dx plus 2x over 1 plus x squared. Now remember, this is going to be your integrating, well, you're going to have to integrate that to get our integrating factor, well, e to the power of that. So just start looking at it and wonder how you could integrate that every time you see that. And when you start to get into this frame of mind, you'll automatically pick up these habits. Like when I just wrote that down, I automatically thought, oh, okay, 2x, if you differentiate the denominator, you get the numerator. So I just immediately thought, oh, differential of the denominator is the numerator, so f prime of x over f of x. So you have to really get into this frame of mind. So nevertheless, that is what it is. It's going to be equal to x to the 1 over 3 over 1 plus x squared. Now the integrating coefficient is going to be equal to e to the integral of 2x over 1 plus x squared. And how do we do this? Well, we're going to have the integral of f prime of x over f of x dx, which is equal to ln 1 plus x squared. Because, sorry, I'm hiccuping. Because that's the denominator, and this is just how we do it. This is just a general form to do that. Cool, so we know that we have I of x is equal to, well, instead of writing the integral of this, we can just write the result for the integral, which is that is equal to e to the ln of 1 plus x squared. Now again, the inverse relationship between ln and e is going to be equal to 1 plus x squared. So that is going to be our integrating coefficient, or integrating factor, sorry. So then what we're going to do is we're going to say y times the integrating factor, which is 1 plus x squared, should be equal to the integral of q of x, which q of x is right here, p of x to the 1 over 3 over 1 plus x squared times the integrating factor, which is 1 plus x squared dx. Again, we just love it when those cancel out. We'll have y times 1 plus x squared should be equal to the integral of x to the 1 over 3. Now, how do you do that? We add 1 to the power and divide by the new power, so y times 1 plus x squared should be equal to x to the 1 over 3 plus 1 over 1 over 3 plus 1 plus c, which means that y times 1 plus x squared should be equal to 1 plus 1 over 3 is 3 over 3, so this should be x to the 4 over 3. And the denominator is also going to be 4 over 3, so it's divided by 4 over 3, which is equal to x to the 4 over 3 times 3 over 4, so it's equal to 3 over 4 x to the 4 over 3. And remember, this is what y times 1 plus x squared is, and when we're talking about the general formula, we just want to get y by itself. So we'll have y is equal to 3 over 4, 1 plus x squared times x to the 4 over 3. And this will be our general solution, and this is for 2017. So that is how you would work that out. Oh my gosh, I'm lost. I forgot plus c over 1 plus x squared. Yeah, my bad, guys. I forgot the c. But this is how you would work that question out. I hope you guys have understood this topic. I'm going to move on to second order differential equations soon, and that one is a little bit more tedious than this, but if you understood this video, you have 100% gotten like a decent amount of marks if this comes on your exam. Differential equations normally comes, but it's probably second order. But if it is first order, you should be good. So thanks for watching.